And gentlemen, how you doing? Welcome back to our severe weather forecast. Looking at what is going on tomorrow, getting ready for this severe weather event. And right now, I got the Convection Outlook up from the Storm Prediction Center and the National Weather Service, checking out what they're saying about the storms here. We got that slight risk that is mainly over Iowa, right there. A little bit of that northern portion of Missouri, and a little bit off to the west over the border into Nebraska, as well as some of the southern and southeastmost counties of Minnesota, and some of the far western counties of Wisconsin. All right, so that slight risk there. I mean, on these edges here, I'm not, you know what I mean. They probably won't be that bad, but you can just, the stronger storms are going to be going over these areas here. So at best, you can see some strong, severe thunderstorms. But around the edges here, you know what I mean. It's sometimes not all that bad unless you have some long track tornadoes, which I don't know what we're looking at here, but that is what we're here to find out. We're going to look at the data and see exactly what's going on and what to expect. There is that tornado risk here. We got that 5% risk for tornadoes going up through Iowa into those southeasternmost counties of Minnesota. All right, and some of those maybe far western counties of Wisconsin. And then we still have that 2% marginal risk for some tornadoes, which outside of here, by hearing about the storm and what I've been hearing about it from other meteorologists and other weather experts and things like that, I would say that an isolated tornado threat is at least marginal out in this 2% risk here. So definitely still probably an environment where we could get even small tornadoes, maybe a few of them, maybe a lot of them. But we're gonna look at the data more intricately to find out. All right, hailmakers. I'm sorry, wind hailmakers here. Wind and hailmakers is pretty much the same outlook right here. So we're looking at it right here. Hailmakers are going to be across this region, mostly because of the dew points of some of the heat. Probably that's going to be in this area. There's going to be a lot of buoyancy. It's probably going to be pretty rich in this area. So damaging wind gusts definitely likely. Hail threat definitely likely as well. So we're going to check out some data here. Now the high-res model is not updated up to the hours of when we're going to have these storms rolling through. So we're going to look at NAM model. Now, NAM model, just to refresh everybody's memory, sometimes when I look at the NAM model, it kind of overplays the threat level. It kind of makes it look more severe than it actually is going to be. But if we look at the NAM models here and we see, exactly what the threat level is as per NAM, then we can get a better idea of what kind of threats that we're expecting throughout this weather event. All right, so let's kind of continue on. This low pressure system moving up into Nebraska. Then you can see that winter weather that's kind of, going up into Minnesota and Wisconsin right there. That's not what we're waiting for. We're waiting for this guy right here. All right, so the biggest worry here is the way the jet is moving. You see this curvature right here. We got fronts that are kind of pushing right here, and then once it gets into Iowa here, it makes kind of this similar kind of looking quasi-linear convective system that looks like, we've got a couple of different waves of these storms moving through, and it kind of looks that way. And so that's kind of the worry too, because we got a couple of different options as far as what could happen as far as supercells and storms moving through this area. Now it looks like the front line here is just going to be marginal severe risk. Let's look towards the southernmost regions going into the Ohio Valley though, and it doesn't look very severe. So that first round, it seems like right here, what we're getting is not going to be really that severe. We're getting marginal severe risk, but I think possibly some stronger thunderstorms out of this, but mostly a lot of winter weather might be associated with that too. Some sleet and possibly some hail. And not very big hail and not very long periods, probably periodical hail and some snow coming out of this, moving into the Ohio Valley, out of that rich area where, ahead of the low, where it's not as unstable. But around the low pressure system right around here, you can see this kind of curving back like that. So you have that instability that's just kind of pocketed in there around the low pressure system, okay? So we have some rain that's moving into this area now. We got some thunderstorms rolling out, a couple little storms rolling out there. All right, and then this moves. Doesn't look like there's a whole lot going on, but let's see. We're still up into the midday hours. Might have something else moving in. Oh, looks like the front is moved out. All right, so let's go back and check out what the NAM is reading because it doesn't look like there's a whole lot of activity there. It never really does on NAM, but let's look at what the atmosphere is doing here. All right, so we got low end tornado threat as per NAM. We got some supercell development and we got some large amounts of CAPE. We got 2,000 joules in CAPE. It looks like a little bit of curvature in the hydrograph here, and right around the low pressure system. That's where that really steep instability is at. Is really right on the low. Where you're seeing that hooking, you're seeing that instability there. It's right on the low. We got supercell development. We got everything right there. Let's look towards the southern end of this line, south of the low. Another tornado risk, but it looks like a low tornado risk. It doesn't look like it's very high. Okay, so I know a lot of people are starting to recently get into storm chasing and things like that, and there's a lot of questions that I've been getting from people learning about storms and how to chase and what to look for and how to read them and things like that. The one thing that a lot of storm chasers may not know is that there's a couple of different types of supercells, okay? And so when we have supercells, there are a couple of variables that change and they kind of there's a couple variables that determine what supercells are going to drop tornadoes and which don't. All right, so if we have supercells with very high wind shear and then you know what I mean, like the surface cape isn't really there on the surface, we got high wind shear, you know what I mean, sometimes supercells can drop tornadoes and not drop tornadoes, but it's depending on the wind shear and the cape. So if you have really high cape on the surface but low wind shear, sometimes they can drop tornadoes because the wind shear up at mid levels it's probably going to be a lot higher up into the storm than what it is on the surface. Okay, but if you have high wind shear on the surface and then you have that that cape isn't really there, you know what I mean, that low cape, I mean, so sometimes things shift and supercells kind of have different atmospherics when they form. All right, so when we look at these hydrographs, sometimes there's different things that it says to us where I'm looking at it and the supercell development is very high, but we have a low end tornado risk. But look at our wind profiles. Our wind profile is around 63 surface state kilometers. So we're having really high wind shear in this area. So that's what makes me feel like some of these, like a lot of these supercells that are developing, yeah, sure, they're going to be rotating thunderstorms, damaging wind gusts are likely, thunder and lightning and hail. A lot of things could come out of this storm. But tornadoes, I would say an isolated tornado risk is definitely possible, maybe up to EF2 damage. You know what I mean? But beyond that, it doesn't look like it's that high of a threat. And if NAM is reading this, then it's actually going to probably be lower a little bit on the HRR model, or it could be higher depending on the accuracy of the HRR model. Maybe the NAM is not agreeing with the HRR. But the point is that it doesn't look like this is an extreme threat here. Oh, we got more models with the HRR. Yay! Okay, great. Let's look at the high-res model. All right, so now we're seeing a different kind of picture here. This front line of storms here, this quasi-linear, it is a quasi-linear system. All right, so we have some stable wind fields on the ground. We got some pretty sufficient cape here. All right, supercell 3.2. We got 72 knots in wind shear, surface to 8 kilometers. All right, so this is that first initial wave of the storms. You can see those lights, those yellows kind of popping up in the northern section here where we're getting that marginal severe risk. And to the north, it seems like this is going to be general thunderstorms. Some of those thunderstorms could be on the stronger side. Yeah, definitely. And the wind field here is starting to kind of pick up and organize a little bit. We have very, very high levels of wind shear, but very low supercell at this point in that first round of storms. Not very much hooking, a little bit of hooking, but definitely not a whole lot. So this first line of storms, severe thunderstorms, it looks like. Possibly some of your hail makers are going to be in that area as well. But it doesn't look, it looks marginally subsevere. Now, on this, let's see if I can go to a regional. Maybe we can zoom this in a little bit. Yay, there we go. All right. That's what I'm talking about. Let's zoom this in and look at some of those cells that are kind of associated right there around the low. Now, the one thing that I am noticing is that some of these cells are isolated, and with isolated cells, it brings up your chances of supercell development. So, supercell development 2.2, this is kind of that early peak to the storm here where it's just kind of getting going. You can see this dashing here. This is actually pretty significant of quasi-linear systems. They actually make these kind of dashy kind of systems sometimes. These kind of dashy individual places to the storms here. Now we do have some significant hail threat that's in this area, low end tornado threat. It's not the highest, but our dew points are up there as far as this hydrograph is saying. And we have over 1,000 joules at Cape in most places around this. It looks like S2P about 1.0, 4.0 on supercell development. So we definitely do have some supercell development in this area. All right, now we get to these isolated cells that our tornado risk jumps up a little bit. Now this curvature in the wind field right here, this is indicative of sustained winds, organized winds. We got some nice flow to that wind shear that's on the surface level right here, and we have enough of it. We got 57, anywhere from 50 to 60 knots of that wind shear in this area, surface to 8 kilometers in the atmosphere. Our supercell is very high, 7.2. And over 1,000 joules in Cape, over 1,400 in Cape in this area here. So these isolated cells, we got a couple of them that are showing up on the high-res model. It still looks like a low-end tornado threat, but it is in zero arc. But our supercell is very high. We have a 5, well, not very high, but you know what I mean. It's like it's high. You know what I mean. It's not very low. It's not very high. It's not like extremely high, but it's up there, you know, 5.0 supercell development. So we have a lot of supercell development in here, but we have a low end tornado risk. And I think that overabundance of wind shear and maybe not enough surface cape, because when we look at these hydrographs, let's look right here south of this this cell here that's a little bit more on the severe side, because you can see that's a little higher of a tornado threat. But look at our surface cape, 1255, but we're getting 1404 in most unstable cape. So we do have enough instability, and our wind shear is lower. Do you see that? So we have lower wind shear, and we have high cape. So that's what I'm saying. Some of these supercells maybe not, they're not in the condition to where it's really technical and really scientific the way that this works. But really all this has to do with is the cold pool. That cold pool that is east of the storm, it's right directly at the bottom, at the base of the tornado, and it feeds the updraft into the tornado, okay? Or, you know what I mean, when it's a tornado. But the secret lies in that, you know what I mean? And so when supercells have a really high wind shear, but a really low surface cape, you know what I mean? They're, more than half the time, they're not going to produce a tornado. If they have really, really low wind shear, but they have really high cape on the surface, sometimes they won't produce a tornado. You know what I mean? So it could go either way depending on the atmospherics of what is going on around the supercell, and I think that that's a lot of what's happening here, is that the supercell, the development is just really ramping it up. It's really getting high. We're getting 6.4, you know what I mean? We're at 5 to 7, you know what I mean, in supercell development. So we have a lot of supercell development, but look at our surface cape in this one, 787. You know what I mean? It's definitely more than enough for a tornado to hit the ground, but it's lower than what we're getting in most unstable cape, which it always will be. You know what I mean? But you know, it's a lower cape, so that's why I'm thinking, you know, we're getting 27 wind profiles, so we're getting that low wind shear, and we're getting that you know, kind of lower end instability here. So, but even with 27 to 45, you know what I mean, knots of wind shear, it means our mid level right here, surface to 8 kilometers, 27, we're getting higher surface winds than we are, you know, kind of up higher in the atmosphere here. All right, so we're getting some surface shear. It's more than enough for tornadoes to spin up, but it's not, you know, it's not 80 knots, you know what I mean? So that's the thing. This thing is kind of switching. It's kind of, you know what I mean, changing, and the atmospherics here are variable as it's continuing along. The hail is really going to be the primary threat, especially if we get up to 2 to 3 inches in diameter hail. But I don't think that's, you know, really accurate. I think it's probably going to be somewhere between 3/4 of an inch to maybe 1.5 inches. You know what I mean? At the very most. That's what it kind of looks like realistically in this situation. But that's just a guess. Don't quote me on it. But look at this. 8.6 we're getting in supercell development. But we're getting lower wind shear. 38 to 28 surface to 8 kilometers in the atmosphere. Our 445 surface cape right there. And most unstable cape around 1500s. You know what I mean? So our maximum peak CAPE in this area, most unstable CAPE, around 1,551 joules of CAPE, but we're getting 445 in surface CAPE. So we're getting a low surface CAPE and lower wind shear, but there's still a little bit of wind shear. Got a little bit of discrepancies in some of those wind fields, and that's really primarily what is the factors of what is keeping this. I wouldn't say marginally subsevere, but keeping that tornado threat low. You know what I mean? It's a low end tornado threat. It isn't zero, but it's a low end tornado threat. It doesn't look like the highest threat that I've seen. I mean, some of the things that I see in the southeast are much worse than this. You know what I mean? So, and then right here, the same thing I was mentioning in the other videos, you get that kind of fine line of very thin green ahead of these storms right here. And this is kind of a bad thing because this means you can get straight line winds out of this. So your winds in the storm and behind the storm are probably not going to be as bad as what you're going to get ahead of this line. So as soon as this line is approaching your area, those winds are going to jump up a couple of notches. You can get some damaging winds before the storm even gets started. You know what I mean? I'm looking about probably about a mile or two, maybe 2.5 to 3 miles, something like that. Those winds will begin before the storm reaches your area. Just because of how fine that edge is right there, you're getting some of those really, really hard winds just ahead of this line of storms as it continues on. Anytime you get that nice sharp kind of edge to it, you know what I mean? Now we see some of these smaller cells kind of popping up to the south. And that's usually kind of a worry because you get isolated cells here in the next frame. See these isolated cells are just kind of popping up like little dashy systems here. And so supercells like to hang out on the southern end, on that kind of southern tip of these storms. And when they do, sometimes they can get that rotation started up. You get that marginal tornado risk going. You got some instability, not a whole lot of surface capes. Surface capes real low. Most unstable cape, though, probably higher in the atmosphere. We're getting a little bit of instability in there, but our wind shear is low now. You know what I mean? So that's why I don't think that we really have enough to really jump these supercells up. Even if they do become supercells, it seems like they're going to become supercells, they're going to ramp up, and then they're going to kind of ramp back down because it seems like either the wind shear or the instability in this situation is not going to be one or the other is just not going to match up evenly with the other one here, So I think that with a lot of that, I think the updrafts are not going to be supportive because one of those are going to fall short and it's not going to supply the supercell with what it needs in order to really, really get things rotating and really get that tornado on the ground. Now, primarily throughout Iowa, right here, especially in the northern regions, I would say that an isolated tornado threat, brief spin-up tornadoes, or just, short-lived isolated tornadoes is definitely possible. All right, definitely possible throughout this region, but to say that I'm looking at the possibility of very large scale, Fujita scale tornadoes, I can't really get there. It's a low-end tornado threat. I think the largest that you're going to get out of this day, maybe a strong F2, maybe EF3. You know what I mean? Something like that. And if we do see an EF3 out of this, first of all, I'll be very surprised, and it probably won't last that long. Because it's going to be moving out of this kind of unstable atmosphere along this low here, you know what I mean? And then not to mention you got rushing cool air that's coming in behind it as well. So it's really, it's pushing it out of there. These storms are probably going to rush out of there about 65 to 70 miles an hour. You know what I mean? Anywhere from probably 55 to, I would say 55 to 65 miles an hour, or somewhere in those the kind of realms there. These storms are probably going to be moving through this region, so it's going to move in and out of your county rather quickly for the most part, especially with the fronts behind it pushing it off to the east and northeast. It's going to get in, it's going to get out, and it'll be done. All right, so. That being said, I think that there is a tornado threat there, but I don't think that it's a massively huge tornado threat. All right, so timelines. We should go through the timelines. I didn't go through the timelines. We were looking at all the data. I wasn't paying attention. Let's go through the timeline here, and we'll go back to the 5th at 15Z. All right, we're going to roll through, and we're going to see that first line of storms come up. All right, that first line of storms coming up in the afternoon to the evening hours of the 5th. All right, going into the overnight hours. Then you start that first line of storms moves out, starts going into Wisconsin and the Ohio Valley. All right, now let's look at the second line of storms. Now those first cells are going to be popping up, it looks like, right around there in Nebraska, they start kind of showing up a little bit. A couple little rain showers here. Nebraska, I think you're gonna, be just fine because we do have a tornado threat there as well. But well, yeah, we do have an isolated tornado threat there. Yeah, definitely. Those western counties of um, Nebraska. So let's back up. We see that first initial line of storms that's kind of coming through starts to show up in Nebraska. All right, we start to get marginal severe risk. Okay, so around 17Z on the 5th, then you start to see those storms kind of popping up. That first initial round of severe thunderstorms moving out into Iowa, out of Nebraska. Then you start to see these isolated cells start to pop up. This is the period here where it's just kind of getting going. All right, now we start to see isolated cells pop up just north of the low pressure system. All right, marginal tornado risk with this, but supercell development's very, very high. No surface cape with this. Most unstable cape over 1100, but really, really high wind profiles. Look at this, 80 knots, 75 to 80 knots of wind shear. You know what I mean? So we're getting a really steep wind shear with this as well. This low moves through Nebraska out of the region here. Marginal severe risk behind the storm, just ahead of it going into Iowa, then we start to get that tornado risk. Supercell development, we got some significant supercell development with this at first. Nice curvature right there a little bit in the wind field, stable wind field with this. Hooking is starting to kind of show its shape here in the hydrograph, not really there yet. And very high levels of CAPE, very high levels of instability right there on the low pressure system right there. So that definitely would make sense. Now our wind profiles are lower. We're 53 to 66, surface to 6 to 8 kilometers in the atmosphere. It's a little bit higher winds at mid-level than we are getting at surface or lower level, but we still have enough sufficient wind shear down on the surface and at lower levels to really get something spinning up. So we have some supercell development with that. All right, that's 21Z, the evening hours of the 5th. That kind of pops up and shows up there. We got some other isolated cells to the north in Iowa as well. These don't look as promising, but we have steep instability there. We got some wind shear, higher on the surface actually than it is up at mid levels. We got some supercell development. That wind shear is probably a product of that. Our dew points are not really that high. I was kind of surprised about that, actually. So going into the further evening hours of the 5th, we're looking at 22Z right now, going into the later hours of the day. And then you start to see that those frames that I was showing you here. We got some more instability that's moving through there. We got some more hooking in that hydrograph. These isolated cells here are probably going to be the biggest problem right around that low pressure system. That low pressure kind of moving into around the mid region of Iowa. North of that, you start to see these isolated cells popping up. These are the ones that could drop your tornadoes and possibly some hail. That's going to be the biggest problem there. Now, at later evening hours, 23Z on the 5th, those cells kind of moving northeast through Iowa. You get that jump up in tornado threat right there. All right, so we got some steep supercell development. We got over 12 to 1300s in instability, but our wind shear is a little bit lower. Still enough wind shear to maybe get something spinned up, but a little bit lower wind shear with that, and our dew points are down to 47. So we do have some moisture in this area, but looks like our dew points are around 47, that kind of area there. These isolated cells here are the biggest problem. If you're gonna get tornadoes, you're gonna get them right here in these isolated cells around that low pressure system. It's gonna stick right in that low pressure. That's where it wants to be. Lower wind shear down here in this one as it's continuing on. Surface cape is around 759. We're getting lower, not low, but lower surface cape. Most unstable cape around 1200s. Still 47 it looks like around there in dew points. All right, and then as that moves out, this is going into the 6th, the overnight hours in the 6th, the very early morning hours. That storm's going to move across with that sharp edging. Still got a little bit of tornado risk around there, and supercell development is very, very high at this point right now. We got 9.0 it looks like on supercell development, which is pretty high, but our surface cape is 281. Very low instability on the surface. Most unstable cape 1400s, but look at our wind profiles, 37 to 23. Lowest to highest, 37 to 23. So we're getting very low wind shear. I think that this is safe to say that this supercell is probably not going to produce a tornado. I just don't think it has enough. There's a high chance of supercell development. It's going to be there. You're going to get a supercell out of this. But the you know what I mean, the chances of it really producing a tornado and reaching the ground, I would say iffy. You know what I mean? I don't even think I would call it 50-50. I think it's a very low chance just because of the way the atmosphere is looking. So that's what we're having here throughout this entire storm is situations where we're getting very low instability, very low cape on the surface. We're getting higher cape, most unstable. You know, our most unstable cape is up there, but our dew points are a little bit further down. We're getting 46 in dew points. Not a whole lot of moisture that's going on here. All right, supercell is lower in this one. Marginal tornado risk with this. Not really much happening with that. To be honest, going and then in the early morning hours here. Let's continue with the timeline before I continue with that. 02Z. This storm starts to move up into Minnesota. Excuse me. Minnesota, looks like you're going to have that marginal severe risk. These storms are probably going to start to lose their punch a little bit. Marginal tornado risk does continue on for a little while, but same thing. Low surface instability. You get very, very frequent, very periodic points throughout this between Nebraska and then moving up northeast into Iowa. You know what I mean? It's about this range right here. That's where that instability is the steepest. So if you're going to get tornadoes, they're probably going to be in this region right here. That's where it's most likely. That's what I'm seeing. Because that's where that instability is really rich. And then after that, that surface instability rises and it actually sticks up there at mid levels, which, what happens at the top of the storm can't happen at the bottom. But we're not getting a lot of instability and really significant low pressure on the surface. We're getting it higher up. You know what I mean? Or our wind shear profiles are just not sufficient. You know what I mean? So I would say isolated tornado threat, but it's a low end tornado threat. That's realistically what I would say. I mean, honestly. I mean, looking at this whole thing, and I think that your primary threat throughout these storms as they continue on here is damaging winds and hail makers. Hail and damaging threat, or hail and damaging winds. I think that's honestly the primary threat. And then, of course, with these storms moving through, torrential rainfall, you're going to get a lot of that. Some thunder and lightning. It's going to be one of those nights where it's just difficult to go to sleep. It's going to be noisy. It's going to be loud. A lot of things going on, things blowing around. At times, you know what I mean? Because at times those gusts are gonna, they're gonna run up a little bit. You're gonna get some wind gusts out of this, and then that wind is gonna die down. Especially when this storm gets to this point here, where you're seeing that kind of fine edge around there. Those winds are gonna pick up a little bit, just ahead of this line. Let's look just ahead of the line and see what the wind profiles are doing here. Not very much. It looks like actually very low wind shear, which is kind of strange, just because of how kind of fine this looks. I think that some periodic damaging wind gusts is probably likely, even though our wind shear is pretty low and our surface instability is very low. So I mean, it really doesn't look as bad as some other people have made it out to be. I know that there was an individual saying that there was a possible chance for a very large, one very large tornado, but I mean, honestly, I don't really see, the possibility of a large long track damaging tornado. I just don't see it here. I don't think that we have that unstable of an environment right now throughout this storm. I would say, isolated tornado risk is definitely possible up to about EF2. Beyond that, I don't think it's realistic. That's just my opinion. And that's looking at the, HRR model. Let's go back and we'll check out the FE3 model just to be sure. All right, so let's check out the FE3 model. This is kind of a relatively new concept. Using this FE3, and then you start to see these cells popping up just ahead of the low pressure system here. Marginal tornado risk. It's reading marginal tornado risk with some of these. All right, 894 most unstable. Okay, 3.7 and supercell development. All right, that's that first initial round of storms, it looks like. And this one's kind of painting a different picture. It's not actually looking like a quasi-linear system now. It's actually looking like a multicellular system where it's moving through, and you get these individual cells kind of moving through Iowa now. And some of these are marginally tornado risk factors, but the FE3 is not reading the threat as high. Well, in that kind of respect, it looks like the same kind of thing, marginal severe risk with a lot of these storms. All right, now in the further western kind of regions of Nebraska, we're getting a nice big break in the caps there. A little bit of boost in heat here too. A little bit of heat that's going up in there. A lot of moisture, but our dew points even in this area are reading around 48. Which if the dew points are around 50s, it could be an unstable environment enough for some tornadic activity. That's definitely possible throughout this kind of area here. Looking a little bit closer to the low, let's look right pretty much directly on the low. We got a marginal severe risk. All right, nice break in the caps right there. We got some instability that's in this area. Not very steep instability, but definitely not zero. We have some wind. Not a whole lot of wind shear though. All right, moving into Iowa here, FE3 model, see what it's reading. All right, marginal severe risk with that. Nice break in the caps there. Lower instability. It's reading a lot lower instability and wind profiles and supercell development. It's reading a lot of low indices on a lot of this stuff. Now, I don't know exactly what it is that's making these models look at this picture much more differently. You know what I mean? But the severe risk is very, very sub-severe in the FE3 model. Then it's a lot less severe than what the high-res model was seeing. So it could go either way. I mean, honestly, I don't think that this is going to be that bad of a situation. I think that this is going to be a marginally, for the most part, I think it's going to be mostly sub-severe. I think you have some damaging wind threat and some hail threat at times throughout this storm, kind of moving out and moving through. I think that's honestly going to be your primary threat. You know what I mean? Because the supercell and the FE3 here, it looks like it's very, very sub-severe. You do get these multicellular systems, which, I mean, in the south, especially in the southeast, yeah, definitely, you would have a whole lot of supercells out of this just because of how much theta E that you would get in those regions. That southerly kind of wind, along with those westerlies that's coming around here with the front right here, you would get a lot of rotation out of this multicellular system like this. But to be honest, you know what I mean? It doesn't look like it's going to be that kind of a situation here. But I mean, even with that, we do get that marginal tornado risk, and and I have never chased in Iowa, so I don't know exactly how they're different from the south in Iowa, but I do know that they do get tornadoes, and I know that Nebraska does get tornadoes as well, but I've never chased in those states. I'm sure that a lot of chasers watching this video have chased there. Maybe you can ask them; they have a lot more experience with those kind of environments up there, but it doesn't look like it's going to be a massively severe day. I think that it's going to be, for the most part, that isolated tornado risk and that wind damage threat and that hail threat moving out through Iowa and Minnesota. And the only reason that Minnesota, that kind of threat, kind of goes up to your far southeastern counties here is because that low pressure system's moving right through that neighborhood, and that's those southeastern counties. But by the time that it moves up there, it's running into cooler air, it's running into more stable atmosphere, and it's just kind of losing its punch. You know what I mean? It's just none of these are severe. You know what I mean? And then it just turns into some rain and some snow and some sleet and winter weather. You get some marginal severe risk. A couple of these thunderstorms, like I said, could be a little bit more on the severe side or on the more active side. But as far as that, none of this stuff is really looking all that severe. I mean, this is marginal tornado risk. Yeah, sure, we get some really high winds here, but damaging wind threats, that's what I'm talking about. Damaging wind threats, possible. 2.5 on supercell, a little bit of supercell development, but look at our instability. 180 on surface cape, 323 most unstable cape. I mean, I don't really think much is going to come out of that, but we are getting high winds ahead of this. All right, so definitely going into Illinois. Then you start to see these storms coming through Illinois here, and some of these, yeah, those winds jump right up. You see what I mean? We're getting 86 to 74 there in winds, in the FE3 model. So this is by the early morning hours of the 6th. So the time frame is actually a little bit different than the high-res model. Same kind of concept. Going into the afternoon, evening hours of the 5th and into the overnight hours of the 5th, into the early morning hours of the 6th. This storm is blowing out of this region, moves up into the Great Lakes region, becomes winter weather essentially, where you can see rain and snow and sleet possibly in some of these areas, especially with that cold air moving through, and actually the cold air that's north of it here. So a lot of this could turn real cold real fast. So you could get some ice out of that. But down here to the south, damaging wind threat. Just because of where that low is, you get this curvature here with that front. You're going to see that front when it comes through, and they'll show you that, and it's going to be blowing these off to the east, and you're going to get some damaging wind threat with that, especially with these wind profiles as hard as they are. You know what I mean? Not a whole lot of severe risk, like I said, but look at our wind, 70 to 92 knots. You know what I mean? It's just it's a lot of wind. So damaging wind is definitely possible in some of these areas here. All right. And then after that, you start to see, those cooler temperatures move in behind this. That front kind of blowing into the Gulf, to the Great Lakes region right here. And it's going to cool things down. You're going to have some nice quiet weather after that. All right. Let's go back to the high-res model. All right. And go to the national, because I know now our next day that we're going to have to look at is going to be on day 3, where we're getting the severe possibility for Arkansas. All right, let's see how much of this that we can actually see without running out of frames here. Not very much. Yeah. All right, so we're going to go to NAM model. All right, so we're looking at the 6th. Okay, then we start to see that low pressure system showing up there right over Texas. You get that first kind of initial line of storms. That low pressure system moves up into Missouri, where we're seeing a lot of that kind of dashy systems here. Okay, so let me look at this, because there's going to be a lot more involved in this. A lot more. All right, so we got Missouri here. All right, now Missouri, we're looking at your southwest counties already. We're getting some instability, and now, like I said, we're gonna look at this NAM model. Don't let this freak you out, because of that hydrograph that I just pulled up here. It looked like the tornado threat on that NAM hydrograph was extremely high. So, but like I said, don't let NAM scare you, because sometimes NAM can overplay those threats. It can kind of, blow it out of proportion just a little bit. All right, so we're getting marginal severe risk. Our wind profiles are very, very high. Our supercell development in that frame is low. See, I wish that I could get kind of a better position on here, because this is just kind of an annoying sort of position here. Yeah, I can work with that one. Okay, so let's look at this back in Oklahoma, because it doesn't show up very accurately. Okay, so we have some tornado risk here, 7.5 supercell development. Alright, so we got over 1,000 in most unstable cape, 957 surface cape, and very, very high wind profiles. We got nice hooking in that hydrograph there. We got a nice, stable, strong wind field. Caps are broken. We got heat. We got moisture. Dew points around 55. Alright, so that's making for... Okay, let me go back. Let me see how this kind of rolls out. Alright, so that low pressure system is up in northern Texas, moving up into... Alright, so that tornado risk is kind of hanging out in Oklahoma here for a little bit. I'm going to go back a little bit just so I can see right from start to finish here, just to get an idea of what is going on here. We got a lot of moisture that is in that area there, but our dew points, it looks like down T 49. Alright, so we got relative humidity that's 97% in this area. Okay, moving up, we start to see those cells start to develop here in southeast Oklahoma. That tornado threat jumps up quite a bit. Significant hail, so we're going to get some hail makers out of this. That instability is already there. That is pretty wacky. Alright, and we have a low-end tornado threat at this time. This is on the 6th at 21Z, so we're going into the late hours of the 6th. So that means that this whole thing is going to be happening in the overnight periods, and it's annoying to me right now because I can't see the cells. All right, but complex reflectivity, we're looking at some of that on that southern cell there. Low end tornado threat with this. Supercell development is 4.9, so we definitely have enough instability. We have enough supercell composite in that area. Boost heat and moisture. 57 in dew points, it looks like, around this. And high wind profiles of 71 knots, surface to 8 kilometers in the atmosphere. All right. Then we start to see these popping up here. We got one cell that's out to the back right there. Marginal severe risk with that. So it's got to be in this blob of storms here. We look right here in the middle of this, and that's when we're getting that higher end tornado threat. Let me look at the time difference between this. 21Z to 700Z. It's not a whole lot of time. Looking at the matter of a couple of hours here. So in the matter of a couple of hours, this jumps from this to this. So that storm is actually moving through. It's actually blowing through rather quickly. To the north, marginal severe risk. Not really much, it looks like, with this kind of blob of storms here. It looks like that kind of northern region of it is going to stay mostly subsevere for the most part. Alright, OPRH is just reading Omega, Omega's reading rain. Okay, so now let's look right here in the center of this. I'm just trying to get the storm structure a little bit. That's going to be behind the line of storms then. That means that line of storms is going to be right here. So right here is where that line of storms is going to be. There is going to be a line. And we have significant, very high supercell development in this area. Over 1,000 joules of CAPE. Surface all the way up to most unstable CAPE here. 57 in dew points. Alright, so, and wide hooking in the hodograph. Nice hooking structure right here as well. Stable wind fields. 91 knots, surface to 8 kilometers in the atmosphere. Got a break in the caps there. It's a tight break, but it is a break. LCL is very low. We have all the ingredients for a great tornado day going across Oklahoma. Anywhere we look, that is a very, very high indice. So I think that, okay, so through the Oklahoma, you're going to have a bad night. I hate to say it. It's going to be a weather active night for you. If you are in eastern Oklahoma, anywhere in eastern Oklahoma, right here, by the time it is, I would say by about the 15Z hour, so you're going into the afternoon of Oklahoma, it's going to look clear and like nothing is wrong. But it's going to fool you, and you might get some of that. The only indication, and especially if you're new to living in Oklahoma, the only indication that you're going to have is you're going to have kind of that soppy, wet, hot kind of feeling before this storm comes up. It's almost going to feel like you're in the jungle or something. You know what I mean? Where it's wet, it's moist, it's hot, it's muggy. You know what I mean? You get that kind of feeling right there as these storms are approaching. So by the afternoon of the 5th, or I mean, I'm sorry, of the 6th, not the 5th. I'm sorry, of the 6th. By the afternoon of the 6th, anybody who is in eastern Oklahoma, you need to get weather aware. You know what I mean? By this time, you have to have, and you have that plan in place. Have a place for you to go to be safe. Preferably underground is best. Going across eastern Oklahoma, anywhere. I mean, I'm just saying half of the state right here. You know what I mean? This eastern portion and this eastern half of the state, all of you need to be extremely weather aware going through this. You know what I mean? On the 6th. You know what I mean? Because we're looking at the 7th in the overnight periods right here. This is 21Z on the 6th, and this is, basically midnight going into the 7th. All right, so that storm's already rolled through in that amount of time. We're looking at the period of 2 hours. You know what I mean? Pretty much. 22, 23, and then 00. You know what I'm saying? So 2 to 3 hours we're looking at this, and this is already pretty much blown all the way up into northeast Oklahoma. So overnight period, it's going to blow through, and it's going to blow through quick. All right? The other thing, Arkansas. You're already getting an early jump on this thing by this time. The atmosphere in your area going into Arkansas it's right here. It's already unstable. So what you're having here is that these storms are brewing in Oklahoma, and then they're moving up, into Arkansas right here, and then going up into Missouri. All right, so by what it looks like, that low pressure system is moving up. Let me go back to this. That low pressure system jumps from here to here really freaking quick, and then it brings all these storms into this kind of linear system going into Missouri. All right, so I'm going to cover that here in a second, but let me go back to composite reflectivity just so I can see some of the cells that are kind of building up here. So basically, eastern Oklahoma by the afternoon of the 6th, definitely be weather aware, weather ready, have your devices ready, have your warnings going, have all your equipment ready to get in your shelters or get to your safe place, have all that stuff ready because this is a high-end tornado threat. I'm not going to lie. It's definitely one of those days. I mean, on NAM, I know that NAM kind of overplays the threat a little bit, but this does look significant. This does look like it could be a very weather active day going across Oklahoma. All right, so next frame we go into, and this is that kind of linear system that I was talking about that looks like in Missouri, where you're getting these kind of these linear systems shooting off, get renegade cells moving and running off to the northeast. Probably a lot of wind shear with these and hail makers. A lot of these could drop some pretty significant hail. All right, so marginal severe risk. We could get some snow. That's it looks like there's some snow that's going on in these areas. Yeah, rain and snow mix to the north. Anyways, let's look at the southern region ahead of the line of storms down here to the south. Getting that marginal tornado risk. That tornado risk is backing down a little bit. We still have some most unstable cape, but our surface cape is 0 in this frame, anyways. Let's look in the middle of that storm here where the omegas are going to be high. Yep. All right. So marginal severe risk. Not really a whole lot of threat there. It seems like it backs down a little bit. So at this point, that storm is becoming more broad and it's losing its helicity a little bit and just kind of losing its punch. But further here to the south, then we get into Arkansas, those southern regions. Okay, so let me explain this hydrograph here, you know what I mean, with NAM model before everybody sees this and is like, oh my god, you know, so I don't want anybody freaking out, okay? This is definitely probably a higher end tornado threat, but I don't think it's going to be a PDS tour, okay? So by the time we get to tomorrow, and I look at the weather models tomorrow, because I'll do another video tomorrow, and then we'll get into the high res model. It probably won't say PDS tour. NAM is very, very famous for doing this, okay? So they do overplay. NAM overplays the situation a little bit, but storm movement is very, very accurate. It's accurately represented on NAM. That's why I use it. All right, so, but it does tell me that there is a tornado threat in this area. I don't think it's going to be this high, but it definitely could be on the higher end. Even with that, you know what I mean? We get 1,000 in most unstable cape, 958 around surface cape right there. It looks like 12.1 in supercell development, 53 in dew points. Our wind, surface 8 kilometers, about 87. LCL 101 cloud layer. LCLEL, effective shear is 64. So definitely have enough wind shear, and we have enough wind shear, and we have enough instability in this area for definitely a tornado threat. If this hydrograph and the storm structure is correct, we're getting a nice wide hooking on that. And so that would definitely be indicative of some tornado possibility going into Arkansas. A little bit further south on the Arkansas line, then that tornado threat, it's still there. By the time that I look at HRR model, I think that this is going to be a much lower end tornado threat, but I don't think it's going to be as low as what we were seeing in Iowa. I think it's going to be a little bit higher than that. You can see this kind of tail that's kind of spinning off like that. When it comes to the day, you could have a lot of isolated cells in here. So it could be one of those lines of isolated cells. It looks like a lower end tornado threat here, but you could have a couple of cells building up there that would be a last minute kind of prediction. And the way that it's curving like this, you could have embedded supercells anywhere in this line. So that could be, and then damaging wind gusts as well, especially if you're getting a lot of those Boeing features, some of that inflow that's being interjected in there as well. And then the storm kind of seems like it thins out, becomes more of an isolated squall line of storms, moving across northern Arkansas, excuse me. Yeah, we got some supercell development with that. We got marginal instability in this area. We got still have some wide hooking in the hydrograph, good structure, and definitely wind profiles. 81 surface to 8. All right, a little bit further south on the southern line here, and then it seems like that threat kind of jumps down a little bit. Where the instability is not as high, it looks like. Still getting around 53 in dew points, though. All right, that and then going through that, this is in the early morning. So we go from, we go from that. That's where it's going to jump up a little bit. Is that those overnight hours of the 6th into the 7th, the very early mornings hours of the 7th. I mean, we're looking at 03Z right now. It's going to be a very late night, early morning. For most of you in this area. And then at 06Z, 3 hours later, that isolated storm, that isolated line of storms is going to be kind of rolling through there. A little bit lower end threat here. It seems like here in the middle, that threat is a little bit higher, and it seems like that's where that kind of pocket of instability that it's moving into is at. And that could be the reason for that, for the instability here. And then that isolated line of storms might turn a little bit more isolated. Could have some multicellular systems here to the south going through eastern Texas. And it looks like a marginal severe risk with the NAM model. So they could be just severe thunderstorms. Could be nothing, the supercell development could be pretty low in that area. We can check that as well. We can double check that situation here in a minute. And then let me move my regional map here. There we go. And then it seems like it moves out. It goes into Mississippi now. We're looking into northwestern Mississippi, where that tornado threat does carry over a little bit into Mississippi. At least the atmosphere is unstable enough for that tornado threat to carry over. It is a low-end tornado threat going through northern Mississippi, but it isn't zero. So we do have some marginal tornado risk and some tornado risk, especially in the northern regions of Mississippi. All right, going into Louisiana. Going through Louisiana, marginal tornado risk with that. I think that the most you're going to get here in Louisiana, fortunately for you, is some damaging wind gusts and possibly some severe thunderstorms. I think that the tornado risk is going to be relatively low as far as your area. It isn't probably going to be completely zero, but you know what I mean? I think that it's rather low. All right, then we start to get some development, it looks like, on the 7th, going through midday to the afternoon hours. We start to get a little bit of ramping up in some of those storms in Mississippi, primarily in the north. Could get some stronger thunderstorms out of this going into northern Mississippi here. And then in mid-Mississippi, a little bit more of an isolated line of storms. Looks like marginal tornado risk pretty much all the way across this. I don't think it's going to be on the extreme end of tornado threat. To the north, we start to get the stuff moving through Tennessee as well. And, I think honestly it's just that flushel of instability in this area. It looks like it's not very unstable, as far as the Cape is concerned. So I really wouldn't worry too much. It just seems like it's kind of carrying over to the east a little bit and then kind of shrinking down before it diminishes. And that's kind of what that looks like, that instability and those dew points in that area. Marginal tornado risk for northwestern Alabama, moving into the later hours of the day on the 7th. And then eventually we get this kind of pulling into Alabama here. It looks like it's going to be pretty broad by that point. We do have a tornado risk, but it is a low-end tornado risk. So that's okay. So that's that theta E that I was talking about. Let's look at this here for a second before we get ahead of ourselves. All right, so this is on the 5th. So we see that that humidity moving up, and that's that periodic. Okay, so you remember that. That's that periodic kind of point here where I said that instability is going to jump up a little bit, but we have that instability there around 56 in some of those regions going through Iowa on the 5th into the 6th. That humidity moves out of that area and moves further to the east. All right, and then, but look at the, but look at this. So the 6th, and then we already got dew points in the 60s on the 6th, and then going into the 7th. All right, so that's that theta E. You can see that southern flow that's moving in there, that theta E moving up in there, and it just kind of collects, and it's kind of hanging out in that area before the front is pushing it out to the east. All right, so it's carrying that instability off to the east before it and it reaches all the way through Georgia before it starts to dissipate and back down, and then it's being taken over and dominated by high pressure and cooler temperatures and much more dry conditions. We do have a couple of those plumes. There's a plume right there of moisture that's moving through the area. All right, before that Lee cyclone kind of situation here moves through there and is taken over by the colder weather here. But that instability here, this theta E advection right here, that's what this is. A lot of heat and a lot of moisture flushing up into this area here, and that's going to aggravate those areas for unstable environment, and that's going to really ramp up those storms. That's really going to give it its little punch to really get going here. All right, so that is going to be kind of a questionable factor going through these storms as they kind of continue on. Then we can kind of see, the NAM is not really probably predicting this very accurately at this point because it's a little bit further out, but this is the last frame here. We got steep, significant instability, some possible supercell development in this area, low-end tornado threat, hooking in the hydrograph, good structure. We're looking at, the overnight hours of the 7th into the 8th as this kind of moves out and goes through the southeast and the Gulf states. And with that advection kind of carrying over, it's definitely possible that we could have some severe weather, times throughout the 8th going across this region, especially in Alabama. I have heard from another individual from another group, you know what I mean, where I did give a shout out to Alabama because of their previous history with storms. Alabama is very, very prone to getting tornadoes, so definitely keeping a close eye on that going through the Gulf states as this advection kind of carries over to the east here. All right, so severe weather. Let's go back to the 5th, and right here we'll go about to the 21Z hours, and let's go to the national view here, and we can take a look at some of the severe weather aspects. Let's look at surface-based CAPE. All right, so the 5th, we already got surface-based CAPE in that area going into Iowa. All right, so about 15Z, look at that. It starts to jump up around 15Z going up into Nebraska. We're getting about 800s in surface-based CAPE. That jumps up over 1,000. And then by 21Z on the 5th, we get that surface-based CAPE jumping up over their 1,500 joules. And then it kind of makes that linear kind of looking system right there, that quasi-linear system here. We're getting over 1,000 in CAPE still in some areas, and that moves off into the Great Lakes region and eventually dissipates. Now, going into what we were seeing across Oklahoma, let's look at the 6th. All right, the 6th, 15Z. Let's. I'm gonna bring this up on a regional real quick, just so we can see a little bit more accurately going into Oklahoma and that region. You can see that surface CAPE really jumping up a couple of notches. We got not very high indices yet, but now we start to see those higher spots of surface-based CAPE jumping up over 1,000 in some regions. We get those higher indices there. There's that line of really unstable atmosphere right there. So that kind of gives you an idea around this area where those storms are going to be rolling out, and they're going to be a little bit more severe, or on the severe end. Even up here, we're getting 900s. We're still getting steep levels in CAPE here. Let me move over my regional map here. All right, we're still getting steep instability here. Let's look at the next frame as this kind of continues on. So it looks like it's going to be kind of limited. It seems like there's a limiting factor as far as the CAPE in Arkansas, but it still doesn't take away a lot of that tornado risk. You still have some isolated tornado risk through that area. Moving into Mississippi, still that CAPE jumps up a little bit more. All right. Let's go down to this, where we can see that CAPE moving in there, and the Gulf of Mexico has always got some pretty steep CAPE in it because of the heat and moisture out there. But when you start seeing it kind of reach up like that, that's a product of that theta E development as it carries on to the east. You can see that blowing up there, the front here behind it, that's kind of blowing it to the east. And that theta E advection is just ramping up that instability as it goes through Mississippi and into Alabama. And then eventually when the front is kind of pushing this away, it eventually bend over like this, going through Georgia and dissipate. You know what I mean? It's just kind of, kind of flop right over. You know what I mean? And eventually that cooler and drier air behind it, behind the front, is going to push this out and make that cape kind of dissipate a little bit. And you're not going to have a whole lot of things to worry about there. All right, let's look at some of our severe wind threat that's going to be going through this area here. We're looking at the 5th around 21Z. We already got some wind shear that's in this area, but yeah, so we got some that isolated area here where we're having really high wind shear. It looks around 80 knots. Starts to move up into Iowa, where you can see it moving up into Minnesota. And I mean, we do have some wind shear in this area, but it's not the highest that I've seen. It's actually not as high as I thought it was going to be in this area in previous models. Down in Missouri, then you start to see we do have some wind threat that's going through Missouri into Illinois. And that's that high profile of wind that we were reading on the hydrographs, moving into the Ohio Valley and across this region here. Then we get into what is 6th, 12Z, 15. All right, we get those southwesterlies that are moving into this region here. You can see that wind threat really jump up a lot. So 6 at 21Z, this is that peak time for those storms where we were seeing them around here, 621Z. All right, and then the next frame, 07Z, they move and jump all the way up here to northeast Oklahoma. So we have some really steep wind shear profiles behind that. We can see some of that over 100 knots in NAM model. So we have definitely some steep wind shear that's moving across this region. And then into the 6 at 06Z, it widens out. You see that flow that's kind of moving off to the east. Got that really, really steep pattern that's moving across there. All right, going across Arkansas, then it goes into, well, this is the last frame, so it's really, really that wind shear that's just kind of pushing with the front is what it is. It's, you know what I mean? It's just kind of sitting there on the front. It's pushing that wind shear that's really, really ramping these storms and making them move through really quickly. So the good point is that when these storms roll through, they're probably not going to sit around for long. They're going to be moving through. They're going to move through quick. But that also means that if we do have some tornadoes or some damaging winds, it could be a little bit more on the extreme side just because of how much wind shear that we got kind of pushing through this area. You know what I mean? So it definitely could be one of those days where it's just going to be windy and just a really crappy day like that. All right, so yeah, we're already looking at storm relative helicity in this area in Nebraska. We have a lot of that helicity that's kind of sitting over there. Moves up into Minnesota. You can see that kind of you can see the front there that's kind of pushing it. You got a lot of ridging with this, a lot of forcing. This forcing right here, and a lot of times that can be indicative of very hard straight line winds. Periodically, because that wind shear does drop off quite a lot, so you can have those straight line winds and that wind shear just really ripping through there. You see all that? That's that really, really thick ridging and forcing behind that, and that's that front that's behind the storms that's just really, really just pushing this whole thing, through. And that's a lot of the reason, I think, for a lot of the damaging wind threat and a lot of those higher wind profiles moving through there. All right, that helicity continues on, goes through Kansas, and then it starts to ramp up again in Oklahoma around the 21Z to midnight hours of the 7th, and then continues on into Arkansas. And you can see that helicity just really, that's just kind of sitting there in that area of low pressure and moving up there, and it goes through Mississippi and Alabama. Not very high helicity there in Mississippi and Alabama, but definitely not zero. Definitely enough, possibly, to get some storms rolling up and to get them a little bit on the higher end or the more severe end. This is just looking a little bit higher in the atmosphere. It's just going to be a little bit more pronounced than what we were seeing on the surface. All right, so energy helicity index, a little bit like CAPE. We're probably going to see similar indices. Yeah, so we definitely got that moving through Iowa. All right, then we get into these later hours of the 6th. There we go, and we start to see that kind of quasi-linear looking system that's going through there, blowing through Oklahoma. Then you can see that that's really that area right there where it's just looking bad. on that southern region of those storm cells, that storm structure that I was talking about there, moving into the southeastern corner, it looks like, of Oklahoma, and then passing off into Missouri here, where in Missouri, you know what I mean, we see some of that tornado threat that's actually lingering up there in Missouri, as well as Arkansas over the line in northern Arkansas. I don't think, like I said, I don't think it's going to be as high of a tornado threat as what the NAM is producing here, but it definitely is not going to be zero. It definitely, you know what I mean, through the overnight hours of the 6th into the 7th, and then later on into the 8th, you know what I mean, anywhere across this line into day 4, you could have we could have a weather aware day here. All right, so looking into Tennessee, it's probably going to look like a little bit, yeah, it's a marginal tornado risk here, but so with that, some of that energy helicity index that's right there on the borders of Kentucky and Tennessee, after it moves east, then you start to get that curve in the northern regions of this, where that instability is kind of folding down. And that theta E advection that I was showing you here, where you start to see it kind of folding down. Let me go to the 7th. You start to see that folding down here a little bit, where it's kind of forcing and it's ridging out of that region of Tennessee and Kentucky, and it moves out of there, and you get that drier, cooler air behind it. All right, so that's what we're looking at right now, right here. All right. And then eventually the energy helicity index eventually dies down. It's probably going to have a couple regions, yeah, I was going to say, where it's going to pop up again and ramp up a little bit, especially in Alabama. Everything ramps up again in Alabama, but it doesn't look like it sticks around for long. It seems like it ramps up a little bit for a period of time, very, very briefly, and then it starts to ramp down and back down again. But because of all that forcing that we're getting with the front to the west, and it's ridging and it's, you know, forcing and pushing it out there, trying to get drier and cooler temperatures behind it, then it's going to be the limiting factor for a lot of these storms to stick around for very long and then be on the very, very high end of, you know, extreme basis here. All right, supercell composite. Let's go back and look at that. Look at all of our details with supercell composite here. Yeah, so we definitely have some supercell composite in this area here. Peaks at times. Not the highest indices that I've seen, especially in Iowa. It's not really all that high. Let's see what it does going into the evening hours of the 6th into Oklahoma. So all around here, this is usually when this happens, you get kind of like this big, wide, multicellular kind of system, but it might not happen like that. So supercell development, you can see that right there. Look at that. Wow. So right here into Oklahoma, crossing across Arkansas, then you can see that supercell composite just really high, going into you know, just that the southern regions of Oklahoma. It seems like it jumps up quite a notch there, going through Oklahoma all the way into Arkansas, into Missouri as well, and the far southern counties of Missouri, where we're getting that higher end tornado threat. So yeah, really, this is going to be the region. Then, you know, look at that. 03Z on the 7th, and then 06Z, we're looking at exactly 3 hours later. That supercell composite seems to back down quite a bit before it, here we go, before it probably is going to ramp up at certain times again. We have a little bit left over heading into Kentucky and Tennessee. But that's when you get that folding that I was talking about with the advection. It ends up folding with the front behind it, forcing and ridging it out of there. And then it jumps up again around Alabama. See right there, like the same thing. Everything ramps up for very briefly, like I said, very briefly in Alabama. It ramps up, and then eventually it moves out of there. And it's going to lower down. You're going to get more of that folding with that advection as that front is pushing it out from the west. And it eventually forces it out of the area. All right, so yeah, so that's a basic look at all the data that I have, anyways, and looking at the factors for these severe weather days. So definitely tomorrow, you know what I mean, in Iowa, I would say by the afternoon hours of the 5th, going into you know, by those afternoon hours of the 5th, you definitely want to be weather aware, especially right here in those very far eastern counties of Nebraska, moving into and over the border of Iowa and into Iowa. Definitely by the afternoon of the 5th, have that weather plan in place. Be at your home or your safe place where you're going to be able to get to a safe place quickly. You know what I mean? Have your weather warnings ready and everything like that. And then eventually, here by the afternoon hours of the 6th, I would say in Oklahoma, especially in those far eastern counties, anywhere along, you know what I mean, basically half of Oklahoma, that eastern half of Oklahoma, by the afternoon of the 6th, have everything prepared, the same exact thing, into the overnight hours of the 7th. Arkansas, you know what I mean? Same thing. Be ready for that into those overnight hours. By midnight, you know what I mean, on of the 7th, or I mean midnight of the 6th into the 7th right here, it's already going to be in Arkansas and Missouri, the southern counties of Missouri. This pocket right here, you're definitely going to have to be weather aware. You know, the 6th going into the 7th, and then through the early morning hours of the 7th, and then the 7th into the 8th, Alabama, you're going to have to be weather aware, the 7th into the 8th, and really the evening hours of the 7th, and then possibly some of the overnight hours. But by the overnight hours into the 8th, it should be starting to really wind down. That's what it looks like. It looks like the evening hours and into the late hours of the 7th is probably going to be that peak time in Alabama here where you could get some severe weather out of that. But we're going to look at day 4 once we get close to it here, and that's going to be probably on the next Outlook that they release here, since we got this. So day 3, I'm going to do again tomorrow. I'm going to look at it again tomorrow. I know that we got this weather event to go through, but I'm going to look at this again because I want to get updated information on this, because the NAM made this look horrible. You know what I mean? Which I don't think it's going to be that horrible, but I definitely think that it's going to be a weather active day. So we're going to look at it again tomorrow with some more accurate data and updated information, just to get a really good, clear idea of what we can expect here. All right, so definitely be safe, everybody, and I will do another video tomorrow. Thank you very much for watching and joining me with this, and I hope everybody has a great evening.